Hello, Dr. Tobias Conroy. How are you today?
Good, glad to be here, Spencer. How about you?
Everything is well. Now explain to me what you do as a serologist.
As a serologist, I study deoxyribonucleic acid, or in other words, DNA. Here, let me give you an example of what that looks like. DNA makes up almost all organisms. In fact, it makes up all the organisms. You see that for all of our viewers tuning in?
Wow. So you're telling me DNA is the reason why I have black hair and brown eyes, and
Yeah, DNA is unique, so nobody in the world has an identical DNA profile, which can be used for a crime scene investigation and can help catch criminals. And a DNA profile looks something like that, where you can match DNA to other people, and everyone has a unique one to them of their own.
that is very interesting. I always wondered how CSI did that.
Yeah, did you know the reason is possible because of DNA profiling? The forensic investigator analyze and compare the structures of DNA, and that's how they find their suspects.
Structure? Isn't all DNA formed in a spiral?
It is, but it's formed in a double helix, spiral, whatever. And there's 4 different bases for the double helix. These letters go across the DNA. These are adenine, cytosine, guanine, and thymine. And here's what you can see it. Okay, it's not really showing up. Please show up. There we go. There we go. There's what it looks like. And those match up and form stuff.
You know, I think some of this is starting to come back to me from biology class. Doesn't only thymine and adenine match together, and only cytosine and guanine match together?
Yes, that is true. Easy way to remember: apples to trees, car and garage. They fit together, they're going to go together.
Oh yeah, the A's and the T's go together, and the C's and the G's go together. I now get how to compare DNA, but how do you guys collect and process it?
We collect and process it. Well, as a forensic serologist, we follow 4 standard steps to collecting and processing DNA. The first is extraction, because before we can analyze DNA, we have to get it first. Common sense. This can be done by getting blood, saliva, or hair samples. Second is amplification, which is the process of production, multiple samples of the DNA. The third process would be, hang on a second, I can't remember the third part. Oh, the third process is separation, which is the process of separating the DNA, obviously, to permit subsequent identification. And lastly, analyzation, which is where we compare the DNA evidence we know as DNA profiling.
I have a question. Where is all this DNA located?
It's all located in your cells, and most of our DNA is located in our nucleus, but some can be found in the mitochondria. And a cell looks like this, with the nucleus being that big red thing in the middle. It's kind of hard to see.
Okay. Wow, DNA is fascinating. I had no idea it was possible to do all of this with DNA.
Yeah, there are more components to DNA than people get credit for. After all, it is the reason we are who we are.
Whoop. It looks like time is about to run up. But thank you, Dr. Conroy, for speaking with us about DNA. It is very intriguing.
Yeah, no problem. I hope one day the world knows all about DNA, because it really is something special. And here's one last picture for all of you people really interested in DNA. Alrighty, there we go. Thank you for your time.
All right, thank you. You have a good day.
You too.